Welcome back to part two of this session. Now we're going to look at differences in emission sources within the agricultural sector and their warming potentials. And as we've seen in the earlier slides, we know that the global food system is responsible for between 21 to 27% of annual GHG emissions. And of these, agricultural activity generates 50% of all anthropogenic methane emissions and 75% of nitrous oxide emissions. And of these, methane has about 28 times the global warming potential of carbon dioxide, while nitrous oxide has about 265 times the global warming potential of carbon dioxide. Here, the global warming potential measures how much heat a greenhouse gas traps in the atmosphere over a specific time, and usually over 100 years, compared with the same mass of carbon dioxide, which has a GWP of 1, indicating how much more potent a gas is at warming the planet. However, here's a cautionary note. You must remember that common statements like methane is X times stronger GHG than carbon dioxide, as you can see in some of these articles here, are inherently oversimplifying, as they cannot really capture the contrasting dynamics of the different gases. And we'll see these contrasting dynamics in the next slide, where even though the global warming potential of methane and nitrous oxide is higher than carbon dioxide has a significantly long-term persistence and exhibits an accumulative behavior, which means that a significant portion of every ton of CO2 emitted remains in the atmosphere for millennia. And the total amount of carbon dioxide ever emitted by human activities commits us to a substantially altered climate indefinitely. Methane and nitrous oxide are shorter lived, as you can see in this graph here. For methane, equilibrium is typically reached within decades, while for nitrous oxide, it takes centuries to reach equilibrium. And they can reach a sustained equilibrium concentration if ongoing emissions are balanced by natural atmospheric removal processes. So for those of you focused on policy, the lifespan of these gases is pretty crucial. Carbon dioxide stays in the atmosphere for millennia, accumulating in a carbon budget. Methane, however, is short-lived and reaches equilibrium in decades. This means that if we aggressively cut methane, we can actually reverse warming relatively quickly, potentially buying ourselves more space in the carbon budget. However, nitrous oxide takes centuries to stabilize, so reductions there are about slowing down future warming rather than immediate reversal. So ultimately, global emission targets need different approaches across energy, agriculture, and different countries. And for methane and nitrous oxide, there is scope to negotiate what the sustainable emission rates may be acceptable for all the different actors. Finally, before we stop for part 3 of this lecture, I encourage you to watch a video of using systemic rice intensification to reduce methane emissions through regenerative production. This is one of the solutions that could reduce emissions through rice cultivation.